Good morning, everyone. Today we're going to take a look at the chi-square distribution. So this is our last distribution type. Thus far, we've talked about the normal distribution, so the z distribution, as well as the t distribution. So this is the last one that we're going to take a look at today. So to just give you some background, the chi-square distribution is a distribution of sums of squares. So when we take a look at the formula for the test statistic, you'll see that that makes a lot of sense. It's the sum of squared quantities. For the shape of the chi-square distribution, it's really dependent on essentially the squared values or the degrees of freedom. So as the degrees of freedom get larger, the distribution is less skewed and more normal. So we're going to talk about how to calculate the degrees of freedom, but from your prior knowledge, I want you to think about how we calculated degrees of freedom before. And does this sound familiar to you? As our degrees of freedom get larger, we're more normal. So think about what that might sound like. And then let's take a look at the chi-square distribution here. So when we have a degrees of freedom of 3, we can see that this red curve here is really skewed specifically to the right because our tail is on the right. But as our degrees of freedom increase, we see that we're flattening out. We're getting to more of that bell shape that we're used to seeing in a normal distribution. There's one thing to note here about the chi-square distribution is that we're not really dealing with means or proportions anymore. We're really dealing with the categories. So this is a categorical type of test, and you'll see what I mean in the example that we're going to take a look at in a moment. But here we're looking at categories. So our degrees of freedom are actually going to be calculated using the number of categories minus 1. So we're not using n anymore for chi-square degrees of freedom. We're using the number of categories, which is denoted with the letter k.